This movie is going to address the different levels of measurement that we use when observing and recording your variables. So we want to think broadly in terms of how you want to describe the variables that you're interested in when you observe your units of analysis. So typically we think of variables in two ways. They're either categorical or they're ordered. And so we want to think about how are they measured. Are we going to put our unit of analysis in some sort of category, descriptive category, or is the unit of analysis going to be measured in terms of rank or amount of something? The three levels of measurement that I'm concerned about you understanding are nominal, ordinal, and scalar. I know the textbook has four levels and it includes ratio and interval, but the computer program that we use to statistically analyze the data doesn't make a distinction between ratio and interval level variables. It calls them both scalar. So I'm not concerned that you can make that distinction. I just want you to know when there is a variable that is scalar and how it's different than variables that are ordinal and nominal. So let's go over some examples. The lowest level of variable measurement is nominal. And this is when you place your units into categories, some kind of descriptive category. Here's an example of a nominal level measure, political affiliation. Let's say you were interested in how people's political affiliation influenced some communication behavior, so you wanted to put them into categories based on their political party affiliation. This is a good set of response categories. It fulfills all of the requirements that are listed there in red on the left. The categories are mutually exclusive, meaning each person would be able to put themselves into a group and only one group. You can't be in two groups. They are exhaustive because we've included other and no party affiliation, so everybody who participates in your study can put him or herself into a group. And equivalent. Each one of these options is a political party. If I had included, for example, Tea Party Republican, that would mess up my category system, right? Because now they would be no longer mutually exclusive because you would be both a Republican and a Tea Party Republican. And they would also not be equivalent because Tea Party Republican is not a party. It's a segment of a party. So we want to make sure when you're designing your categories that they are mutually exclusive, exhaustive, and equivalent. There's another kind of categorical variable where the variable categories are ordered in some sort of logical way. I'm going to show you an example and then we'll discuss what it means by the distances. So for example, if you wanted to ask people how many Facebook friends they had, you could ask them, but off the top of their heads, most people probably couldn't give you the exact number. And if you wanted accurate information, it might be better to give people ranges. So for example, you can see here that we have a set of ranges that allow people to accurately put themselves into one category. But the difference between this and a nominal variable is that as the number, the value goes up from 1 to 2 to 3 to 4 to 5 to 6, so does the number of Facebook friends, right? So we can see that the people who put themselves in group 1 have fewer Facebook friends than the people in group 2, and people in group 2 have fewer than the people in group 3, etc. Now, where it says on the left that is we establish relative position of categories, but the distance between the values might not be equal, here's what that means. It means that the distance between the values of 1 and 2 clearly are equal. That's just one number. But the distance between the actual number of Facebook friends for the people in group 1 and the people in group 2 might not actually be equal. So I could be in group 1, for example, if I had 40 Facebook friends, okay? And someone else could be in group 2 because they have 100 Facebook friends. So that person has 60 more Facebook friends than I do. But there could be someone else in group 1 who has 50 Facebook friends and someone else in group 2 who has 51. And now the distance between that person's group from group 1 and the person in group 2 is 1 Facebook friend. So the distance between the numbers of friends when you've got ranges like this is not equal, but we can still establish relative order. Everybody in group 2 has more Facebook friends than everybody in group 1. Now, when we evaluate these category systems, we want to use the descriptors that are in yellow on the left side of the page. And you can see here in this example that the categories are all mutually exclusive, right? There's no overlap between them. They are exhaustive and includes everybody who has 0 to infinity Facebook friends. They're logically ordered, so as the values get bigger, so does the number of Facebook friends. And they're balanced. There's about 50 people in each of the groups. Okay, here's another very common ordinal level variable, grade level. And now here we don't have numbers as the categories, but we do know that you are determined or you are defined as a first year, sophomore, junior, or senior based on the number of units you've earned. And going from 1 to 2 to 3 to 4 is a symbolic way of indicating the number of units earned. So everybody in group 2 has more units earned than everybody in group 1, and everybody in group 3 has more units than everybody in groups 2 and 1, for example. But again, you could be a third quarter freshman and a first quarter sophomore and be just a couple of units away from each other. Or you could be a first quarter freshman and a third quarter sophomore and be lots of units away from each other, even though you're in group 1 and group 2. Now, the last level of measurement I want to pay attention to is scalar. And this is where the variables are ordered, but there's also equal distances between the values. So typical ratio variables, like age, like number of Facebook friends, like length of relationship, where you fill in the blank with an actual number, these are scalar variables because the number corresponds to something that actually exists in the real world, and there's a measurable difference between the different responses. So if you ask somebody to identify their age and they put 18 and someone else puts 25, we know there are 7 years difference between their ages. They're not in a category of 18 that corresponds to some range, all right, and someone else in the category of 25. We know that there's actually 1 year between 18 and 19, 1 year between 19 and 20, etc. Okay, so that's one kind of scalar variable. The other kind of scalar variable that we're interested in is called interval in the text. And these are scales that are usually used to measure internal states, so like personality states or attitudes or opinions. And again, when you complete a large set of scales and you have a number computed for something like shyness or willingness to communicate, those numbers can be plotted on a number line and there are equal distances between the values. Now, the two kinds of scales that I'm concerned about you knowing are Likert and Semantic Differential. Likert scales are used often to assess attitudes about or agreement with a particular kind of statement. So here we have a level of interest identified going from 1, not at all, to 5, very. Here's another one that agree or disagree go from strongly agree to strongly disagree, and you can circle the box or check a box. And then if you have an illiterate or pre-literate population that doesn't understand your language, you can use symbols like this one here. Semantic differential scales are different. This is where you have oppositely coded words placed on the end of a scale, and you ask your respondents to tell you their attitudes or opinions on that scale. Do they lie closer to the left word or closer to the right word? So for example, these words here would be used to talk about possibly a professor. Is that professor accessible or inaccessible? Is that professor rude or courteous? You can put a check mark on a blank, or again, you can fill in a circle. So it's important to understand variables and measurement because it influences the ways that we can write our hypotheses, right? So we have to know if our variables are categorical or if they're ordered. If they're categorical, we state our hypotheses in terms of difference. And if they're ordered, we state our hypotheses in terms of relationships. And then secondly, how we statistically analyze the data is influenced by the level of measurement. So there are specific tests designed for each different level of measurement, and we'll get to those in the next few weeks. All right, good luck.